Hi everyone. We're going to do two-column proofs. This is the first example, and we have to fill out the reasons, and usually the reasons are similar to this list of vocabulary words with postulates, definitions, and theorems. So given that AL equals SK, so those two equal, we want to prove that AS, this line segment, equals LK. So the first statement is AL equals SK. So that's your given. That's even on our vocab list. And then we're going to do something that we need. We need a L and a S in our final proof here. So I'm going to use the reflexive property of equality and just write LS equals LS. So that's your reflexive property. I'll shorten it here since we already have it written down here. Now what I'm going to do is take my first statement, my given, and add LS to both sides since they equal. So that's your addition property of equality. And that is right here. And then what I'm going to do for 4 is do my segment addition postulate. So where is that at? Segment addition postulate. It's right up here, number 2, right in front of me. So we know that looking at this, that AL, just from that, AL plus LS equals AS. So if L is in between A and S, then that is your segment addition postulate. So we write that down. Postulate. All right. And then what we're going to do for number 5 is we're going to write SK plus LS, we're kind of working backwards here, equals LK. Same thing. So that's I'll just write out segment addition postulate. I'll just do that. All right. And then by substitution, and that's the substitution property of equality basically, AS equals LK. Because you have AS, if we substitute AS as AL plus LS, if we're writing these two down, AS plus LK, and if you're looking at these two right here, well, these two equal each other. Since they equal each other, then we know that if AS equals X and if LK equals X, then these two equal each other because these equal each other. So that's where the substitution property comes in. All right. Now the next one is this one. So we have a hexagon, and it says the measure of angle 4 is 120 degrees, and measure of angle 2 is congruent to the measure of angle 5, and the measure of angle 4 is congruent to angle 5, so this means this is 120. So we've got to prove that measure of angle 2 also equals 120. And so the first part, number 1, is just given. Just copying that down. Now, the measure of angle 2 is congruent to the measure of angle 4 through the transitive property of equality. And that's because we have angle 2 is congruent to angle 5, and angle 5 is congruent to angle, well, let's put congruent to angle 4. And since these are the same, we could say angle 2 is congruent to angle 4. And that's your transitive property, and these two are the same. All right, so that's what you write. And then we need to do definition of congruent angles. That means the measure of angle 2 equals the measure of angle 4. And then finally, by substitution, since the measure of angle measure of angle 4 is 120 degrees, then I know that the measure, if I'm working backwards here, so this is 120, and since C is equal, this is also 120. So that's just through substitution. And finally, I took this and enlarged it in case you want to screenshot it. This should be a property of equality here. And that's it. Thank you. Have a nice day. Bye-bye.